The main way that we use pairs, though, is not for things like rational numbers, but as the implementation strategy for a list. A list abstractly is just a sequence. In the book, you will find a lot of pictures that look like this. This is an abstraction diagram. And what goes above the line here is what the abstract type is that we're implementing, like, say, sequence. Boom, 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 boom. OK? Bunch of things in parentheses, looking suspiciously like a sentence for reasons we'll talk about in a moment. And the way we're going to implement that is this way. So a list, a sequence of n elements, is a set of n pairs. And the car of each pair is an element of the sequence. And the cdr of each pair is the next pair along, except for the very last one, whose cdr is this special thing called the empty list. The empty list is not a pair, but it's the only list that isn't a pair. OK, so this is kind of a recursive definition of lists. A list is a pair whose cdr is a pair, or the empty list. Now, what goes in the middle of the diagram is the constructors and selectors that define this abstract type. And the reason they go there in the middle is these are the only procedures in your program that are allowed to know both what abstract type we're implementing and how we're representing that type concretely. So when I have cards represented as a word with a rank and a suit, I have the constructor make card and the selectors card rank and card suit. And those three procedures are the only ones that know what a card actually looks like in my program. All other procedures either are part of a lower down abstraction, like words, or are things that use cards, like total hand. But total hand doesn't know what a card looks like. It only knows that they have ranks and suits that are represented somehow or other. OK? So the things in the middle are the implementation of the abstract data type. Now, how about this abstract data type of list? Well, what there should be is a constructor called list and selectors called first element of list and rest of list. Instead, this is really the only thing in the language that's quite like this. We use const car and cdr, which is what in other contexts we would call a data abstraction violation. You lose points if you do that, because you're not respecting the abstract data type. The reason we treat lists specially is that lists are only sort of half abstract. So the language really does know about lists. And let me show you what I mean. Suppose I say, I want to do 3/4. So I say const 3/4. I get something that looks like this. Parenthesis, and then the car, space, period, space, and then the cdr, close parenthesis. This is not a list of three things. That period in the middle is a piece of punctuation, just like the parentheses. There's only two things here, the left thing and the right thing. So don't be confused about that. But now if I say this, I don't get open paren 3 dot, open paren 4 dot, open paren 5 dot, open, close, 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 close. I just get 3, 4, 5. Because we have this special shorthand representation for pairs that are hooked together in this particular way to form a list. And since the language knows about lists, it's not as if we're going to change the way lists are represented, so we don't have to treat list as an abstract data type. Okay? Okay. We actually do have other constructors for lists. Yes? How is a list different from a sentence? Okay. A sentence is a list in which the elements are constrained to be only words. Okay? So, well, here. If I do this, I get this interesting thing. I don't get a list of 4 elements. I get a list of 3 elements, the first of which is a list. Because if you look at the picture in the abstraction diagram of what a list looks like, the car of the pair is one element, even if it is itself a list. So one difference between lists and sentences is that you can have lists of lists. Okay? That also means that you can get in trouble. So if I say cons 3, 4, 5, I get this thing with a dot in the middle of it, which isn't what I wanted. I wanted to put 5 at the end of the list, but I failed at doing that because the use of pairs to make lists is asymmetrical. The car of a list is a different kind of thing from the cdr of a list. The car is an element, and the cdr is a sublist. Okay? Yeah. Okay. Why didn't I get, he's asking in this example, why didn't it come out, oops, this example. Why didn't it come out open, open, 3, 4, close, open, 5, 6, close, close? That's what I'd get if I said this, list. Okay? So list is another constructor for lists. It takes any number of arguments. It's a little bit like sentence in that way. And it constructs a list in which each element of the list is one of the arguments. So if you give it 6 arguments, you get a list of length 6. Okay? Cons, remember, look at that picture again of how we make lists out of pairs. So if I say cons to produce this pair right here, okay, what I'm doing is I'm saying stick one new element in front of this whole list. Okay? So when I use cons to make a list, the first argument is an element, the second argument is an already existing list. So just add one element to the front. There's also a third list constructor called append. This acts a little more like sentence. It makes a list of the elements of the arguments. Sentence is different because sentence will accept words as well as lists as arguments and puts them together. In fact, we can do I not have it here? Oh, yeah. here's an implementation of sentence. And at its core, the implementation of sentence uses append. Oops, I've lost my cursor. There it is. Okay, so the essence of it is right here. But since append only takes lists as arguments, first we say, is A a word? If so, make a list of length 1 out of it and call sentence again. Is B a word? If so, make a list of length 1 out of that, call sentence again. So by at most the third time through, we have all lists, and then we can